with Tom Harker. I'm an architect. I was consultant architect to the Joint Committee who ran both the tunnels, Queensway and Kingsway. So that gave me the role of designing the visible bits of Kingsway following its use for about 3 decades, and then starting from scratch, the whole of the visual parts of Kingsway, including the bridges, approach roads, and so on. The tunnel is a result of a study which was made to examine the possibilities of tunnel or bridge. And personally, I would have been very excited to be involved with the bridge. It was a 6-lane bridge. It would have been at least equal to the Golden Gate in San Francisco, but it was not to be, because despite the fact that the tunnel was slightly more expensive per lane, you could phase it, whereas you can't phase a bridge. You either build it or you don't. So it was the tunnel. And the tunnel also offered the advantage that it would connect with the projected mid-rural motorway, the M53, and eventually onto the M6. So it would become part of the national motorway network. And so the design work started on it, providing 2 twin road tubes with much wider traffic lanes, 12 foot wide, and they would be constructed by mechanical means. The civil engineering and structural engineering things were obviously done by Motts. Yeah. And so there was a careful survey of the strata under the river. At the particular point where the tunnel is constructed, it was pretty well the narrowest part of the estuary. And it did offer very good bedrock from the Wallasey side to about within a short distance of Liverpool. So that's where, having discovered the existence of this boring machine in Pakistan, it could be adapted to do the machine work and avoid hand work with explosives and so on. The last bit on the Liverpool side I may have mentioned was driven through clay, and that had to be excavated in a different way with a shield. A pilot tunnel was driven first of all. It always needs a pilot tunnel to confirm the strata, and that was done in 12 months. So that was a fairly straightforward, simple operation. That was done, in fact, with hand tools, drills and so on. You could walk through it. It was about, I would say, 8 feet tall, something like that. An unbelievable bit of kit being obtained from Pakistan, where it had been working on the Mangla Dam. And this thing was almost unbelievably enormous. It was 45 feet long, weighed 350 tons, and had at its front a resolving cutting edge. Behind that, there were conveyor belts to remove the broken rock spoil. And behind that again, a system to line the newly bored tunnel with precast concrete segments. As it progressed, it left an absolutely completed tunnel behind it. Wonderful effort, and did very well, until it got to the mid-river section when it broke down. And it broke down due to the penetration of water and grit into the machine, and it was an enormous dilemma. You couldn't get it back, the tunnel was behind it. The only thing you could do was to somehow repair it in situ, and this was accomplished at enormous risk to the people working on it by excavating a cavern above it and removing the broken part, which was 15 feet in diameter and itself weighed 6 tons. And that was accomplished by working day and night for several weeks, when the Mersey mole, as the machine got to be called, could start again, and eventually it got to Liverpool, not too much behind schedule, and was withdrawn in pieces up the Liverpool shaft. In the meantime, excavation had been going on in Liverpool in the area which is not rock, but was in fact clay, and so the tunnel was then complete. Whilst all that was going on under the river, on both sides of the river, frantic activity was also going on. In Liverpool, a large site was cleared by the demolition of many, many buildings, and the road was sunk protected by reinforced concrete retaining walls in the form of a spiral. The last bit of the road being covered with an 800-foot long vault holding up the buildings on either side. When that was completed, the Liverpool side was intact apart from the vent station. On the Birkenhead side, a large toll plaza had been cleared, and there the administration and control building was being constructed, under which was the line of all the toll booths. The toll booths were situated all there, rather than some at one end and some at the other, to be tidal flow working, depending on the traffic load at any time during the day or night. Beyond the toll plaza, a very substantial civil engineering project was the construction of a viaduct comprised of 12 traffic lanes built over Bidston Moss, which, as its name implies, had no good foundations, and some of the piles of the viaduct went down the extraordinary distance of 200 feet before they reached good bedrock. The ventilating stations for the Queensway tunnel were simply enormous structures with vertically mounted fans. The new ventilating stations for Kingsway were quite modest in size and only 2 in number, 1 in Liverpool, 1 in Seacombe. The fans being laid horizontally in a fan chamber, above which there were the 2 intakes. My sketches for the building show a circular extract tower and circular intakes, and it was a very striking structure. But the committee found it just a little bit too much striking for their water. And so we had to go back to the drawing board and produce a design with a square tower and square intakes. And that is what is now there on the site. They both, however, formed notable landmarks and are described by the guide to Liverpool as looking like a rocket on a launch pad, which I think is still a very good description. I was highly impressed by the way people maintain progress in pretty difficult conditions. I mean, some of my building sites have been very difficult conditions, but nothing quite so claustrophobic and wet as the working site for the tunnel. The water didn't come in from immediately above, as you think. It came in from vertical fissures, some each side of the tunnel, but there's a large ingress of water, and the water brought with it grit. The project was finished pretty well on project time in June 1971. The Queen opening the tunnel at that time in June. The King had opened the earlier tunnel, King George V, in 1934, in front of an immense crowd looking up towards St. George's Hall. Our opening was confined to the fairly narrow entrance roadway. It was packed with workers, families, VIPs, the Queen, the Guard of Honour and the band. So it was quite something. When the Queen pressed the button, we'd arranged that the cargo nets covering the entrance would be moved aside. The internal lights in the tunnel would come on. At that time, we just finished the first tube, but about the same time, they got more money. And so I think we commenced the second tube. I think that's right. Knots were a very special firm and led by very special people, and they were hugely inventive. So as each problem occurred on the Mercer Tunnel, they put their ideas together and came up with an amazing civil engineering answer. They were very, very good.